Problem number 8. The scale is calibrated so that it gives a correct reading when sitting on the ground. A person holds the scale and presses it on bottom sides with their hands, pushing up on the bottom with the left hand and pushing down on the top with the right. The scale has a mass of 5 kg, and their left hand exerts a force of 200 Newton. The reading of the scale is next one. Solution for problem number 8. Because scales in this student hand is in equilibrium, we can write equilibrium equation: force on the bottom equal force on the top plus mg. Here we know what is bottom force and what is mg, and we can count what is top force, which is supposed to be scale reading. That will be 150 newtons or 15 kilograms, which is answer A, and that was solution for problem number 8. Problem number 9. The light board of length L is hinged to a vertical wall. A solid ball of weight G and radius R is held between the wall and the board by a force F applied perpendicular at the end of the board, as shown in the figure below. Both the wall and the board are frictionless. The angle between the board and the wall is 60 degrees. What is the magnitude of force F? Solution for problem number 9. First, let's draw the free body diagram. We have force F1 acting on this ball horizontally from wall, and the force F2 acting on this ball from board. It means that the same force F2 acting from the ball to this board. And when we count what is F2, we can count what is F. Let's count what is the force F2. In vertical direction we have static equation. F2 multiplied by cosine 30 degrees must equalize weight of this ball, G. It means that force F2 equal G over cosine 30 degrees. And now let's count what is force F. Force F and force F2 create opposite torques on the board. We can write static equation for this torque on this board around this pivot. That will be F2 multiplied by radius R over tangent 30 degrees. That's a torque from force F2 acting from ball to this board. That's equal to torque F multiplied by L. And from here we can count what is force F. That will be this expression, and after all, that's 2 GR over L. That's answer B, and that was solution for problem number 9. Problem number 10. A ball of mass small m rolls in a ball bolted on a cart. The ball and cart move together and have a combined mass mc as shown in the figure. Initially the cart moves to the right with the speed v0 with respect to the ground, while the ball is at rest with respect to the cart. The ball then slides down to the bottom of the ball. When it reaches the bottom of the ball, it moves with the velocity vb with respect to the cart. At this instant, how fast is the cart moving with respect to the ground? Solution for problem number 10. Here we can use momentum conservation because there are no friction between cart and the ground. So it means that initial momentum equal final momentum. And there will be equation. initial momentum, which is small m plus mc multiplied by initial speed v0, must be equal to momentum of cart with the ball, which is mcv, plus momentum of this small ball, which is m multiplied by speed v plus relative speed vb. And from this equation we can immediately find what is speed v of this cart with the ball. That will be this expression, and this is answer D, which is a solution for problem number 10.